cover gas stoichiometry at STP and not at STP. So just a review for the general setup for stoichiometry, if you start with the amount of reactants, it could be grams or volumes, you need to convert to moles of the reactant and to the moles of your product. This is your mole bridge. Once again, if you're going from one substance to another substance, you have to be in moles and you use your mole bridge. After you come out of your mole bridge, you can then convert to either volume or grams, okay? So there is a very easy conversion factor for this. 22.4 liters, if it is at STP, is equal to 1 mole. So just like 1 mole equaled the molar mass, 1 mole can also equal 22.4 liters. We are going to practice solving for gas stoich. So you do need a calculator, you do need something to write with, and you probably are going to want a periodic table nearby as well. So just a reminder, there's 2 scenarios for gas stoich. One is at STP and the second one's going to be non-STP. So we're going to start with some problems at STP, okay? It says a sample of nitrogen gas, N2, has a volume of 1.75 liters at STP. How many moles of N2 are present? So don't forget, you did just learn an equality. Your equality was 22.4 liters is equal to 1 mole, okay? So we did just learn that equality, so we don't even actually need an equation here because we are at STP. So we are starting with 1.75 liters of N2, and we just want to convert that to, we're just going to convert that to moles, okay? So if you have liters at the top here, you do need liters at the bottom here. So 22.4 liters is equal to 1 mole. So it's just a one-step equation. And we have 1.75 divided by 22.4. And we get 0.078 moles of N2. Okay? So that one is pretty straightforward. You just need that equality. 22.4 liters is equal to 1 mole. All right, let's try another one. A sample of argon gas has a volume of 3.45 liters at STP. What is the mass of argon? So we're going from liters to grams this time. We are at STP. So our given is 3.45 liters. If you have liters at the top, you know you need liters at the bottom. So we're going to use 22.4 liters is equal to 1 mole. Okay? And then we just simply need to get to grams. So if you have moles at the top, you need moles at the bottom, and 1 mole is equal to the mass of any substance. So the mass of argon is 39.95 grams. And then you can simply do the math. So 3.45 times 39.95 divided by 22.4, and you get 6.1 grams of argon. Okay, so this one is pretty straightforward. Just liters to grams. Make sure you use the 22.4 liters is equal to 1 mole. All right, let's try another problem. So we're going to do another equation with gas reactions at STP. We want to calculate the volume of carbon dioxide. So we're looking for liters of carbon dioxide produced at STP from the decomposition of 152 grams of calcium carbonate. Okay. So according to this reaction, we have our equation. Our arrow got bumped down, but that's still where our arrow falls, okay? You always want to make sure that the equation is balanced first, and in this case, it is. Since it is at STP, we are just going to do a straightforward reaction, and we won't need the ideal gas law. So we have 152 grams of CaCO3. Since you have grams at the top, you need grams at the bottom. So you need to get that formula weight from the periodic table. So you have 3 oxygens plus carbon plus calcium, which is about 100.01 grams, and that is equal to 1 mole. Okay? Now, since we have moles at the top of calcium carbonate, we need moles at the bottom of calcium carbonate. Okay, this is going to be our mole bridge. We're going from one substance to another. Our coefficients are 1 here, so it's 1 mole of calcium carbonate. We're going to carbon dioxide, So it's 1 mole of CO2. And we are not looking for moles of CO2, or we could stop right there. We want liters, so we take it one step farther. Since you have moles at the top here, you have to have moles at the bottom here. 1 mole of carbon dioxide is equal to 22.4 liters, and then you can solve. You want to multiply the top and divide by the bottom. So 152 times 22.4 divided by 100.01 is 34.04. Let's change this color font here so it shows up on my black. So 34.04 liters of carbon dioxide, okay? It is a longer equation, so if you do need help, make sure you do ask your teacher. This was at STP, okay? And now we're gonna start to do some that are not at STP, so we add a second step. All right, we can see here that the sodium azide, NaN3, is used in some automobile airbags. The impact of a collision triggers the decomp of NaN3 as follows. We have the equation here, it is balanced. We want to calculate the volume of N2 generated at 80 degrees Celsius and 823 millimeters of mercury by the decomp of 60 grams of NaN3. I put it here, I'm going to solve on the next page. Just so I have more space to solve, I just wanted to set it up for the scenario on the previous one. Okay, so we want to calculate the volume of N2. So we're looking for volume, that's going to be our X. We know the temperature is, this is volume, is 80 degrees Celsius. The pressure is 823 millimeters of mercury. And the decomposition is 60 grams of NaN3. Well, we have 60 grams of a different substance. So before we can do the ideal gas law here with our moles, we need to get 60 grams of NaN3 to N2. So we need to convert that over, okay? So I'm gonna start with my 60 grams of NaN3. If I have grams at the top here, I need grams at the bottom there. Plus 22.99. So my mass is 65.02 grams, and that is equal to 1 mole of NaN3. If I have moles of NaN3 here, I'm going to have moles of NaN3 here, and my coefficient is a 2 because this is my mole bridge. Okay? And I'm going to moles of N2, so it's going to be 3 moles of N2, okay? So I'm gonna solve this and get my moles of N2. I'm gonna multiply the top, so 60 times 3 divided by the bottom, which is 65.02 times 2 is 130. So 180 divided by 130.04, and you get 1.38 moles, okay? So we can plug that number in here because now we have the moles of N2, which is what we need. So we have P, we have V, we have N, we have T, and we also know our R. Since our pressure is 823 millimeters of mercury, our R is going to be 62.36. Okay? So now you can easily use the ideal equation to solve for V. I'm going to erase this just so I have some more room so I can solve and use the Pivnert equation. Okay. All right. So for Pivnert, just a reminder, it is PV equals nRT. My P is 823. My V is my X. My N is 1.38. My R is 62.36. And my T is in Celsius, so I do need to convert that to Kelvin. So 80 plus 273 is 353. And then I can solve for my V. So 823x is 1.38 times 62.36 times 353. So this is a really big number, so 30,378.05. We need to get x by itself, so you divide each side by 823, and our x is 36.9, and we were solving for volume, so the answer is liters. okay? Does your answer match mine? If not, you need to ask your teacher some questions, okay? We have one more problem that we're going to do together that is also not at STP. Aqueous lithium hydroxide solution is used to purify air in spacecrafts and subs because it absorbs carbon dioxide, which is an end product of metabolism. We have our equation here. It is balanced. It says how many moles of lithium carbonate will be made from 17 grams of carbon dioxide, and we want to calculate the volume of lithium carbonate made if the pressure inside a reaction chamber is 0.79 atm and the temp is 312 degrees Kelvin. Okay, I'm going to solve on the next one. So once again, we can set it up. We have 17 grams of carbon dioxide, and we want to calculate the volume. So this is going to be my X. The pressure inside of here is 0.079 atm. The temp is 312 Kelvin. Okay. The N, we have to convert this over here. And then our R, since this is 0.079 atm, our R is going to be 0.0821 for atms. Okay. So we need to get our N's first. I'm going to change colors just so I have some room and can write in the black. I'm starting with 17 grams of carbon dioxide. I have grams of CO2 at the top. I know I need grams of CO2 at the bottom. This number comes from the periodic table. It is 44. It is equal to 1 mole of CO2. If you have moles of CO2 at the top, you need moles of CO2 at the bottom. The coefficient for CO2 is 1, and we're going to lithium carbonate, so it's also a 1-to-1 ratio this time. Okay? So then you can multiply the top, so 17 times 1 times 1 is 17, divided by the bottom, so 17 divided by 44 is 0.38 moles. Okay? You can plug it in here, 0.38 moles, and then you can use the Pivnert equation to solve for your X or V in this case. I'm going to erase this just so I have some room. Okay? And then we're going to use Pivnert to solve. So PV equals nRT. My P is 0.079. My volume is X. My N is 0.38. My R is 0.0821. And my T is 312. And now I can solve for X. 0.079X is equal to 0.38 times 0.0821 times 312. And you get 9.7. And then X is going to be 0.079. So 123.2 liters. Okay? So I know we covered a lot. We covered a lot of gas stoic with and without STP. If you need more help or have questions, talk to your teacher.